On the back side of our note-taking guide, I'm going to show you a couple of different ways on how to type in the cotangent in the calculator. You can either do the cosine, and again, I use my fraction feature. If you do not have the newer updated calculator, you're going to have to type it in with parentheses divided by button and the sign. Or remember, cotangent is 1 over tangent, so you could do tangent. Now, how would you type in the cotangent of pi over 2? If we did 1 over our tangent of pi divided by 2, the calculator doesn't like that. It says there's an error. But if I type in the cosine of pi over 2, divided by the sine of the pi over 2, then the calculator is perfectly all right with it. And why is that? Remember back from the other page, the tangent of pi over 2 is undefined. The calculator knows that, so you can't put 1 over the tangent of pi over 2 in the calculator because the calculator will balk on that. Determine the period of the function. The period of cotangent is typically pi. And we take our period and we divide it by the number in front of the x, or being multiplied with the x. So pi divided by pi over 2, you keep the first number, multiply by the reciprocal, and simplify. So our period is 2 in this problem. In the next problem, the period, pi divided by the b, and in this case our b value is pi, so our period is 1. When we move down to sketch one cycle of the graph, in my classes, remember, we did 5 key points for sine and cosine. With tangent and cotangent, we have 3 key points. Our key points from the other side, I'm going to go ahead and put those into my calculator and my list. For those of you that are watching and you don't know, the stat button is 2 buttons from the green button, and the number 1 is the edit, and we're going to edit this list. And what I have done is I've got stuff in here, so I'm going to arrow up so that the list 1 is black, and I'm going to push clear and then enter. You do not want to push delete, or it will delete the entire list, and this whole column will be gone. Okay, so you don't want to do that. I'm going to put my x's and my y's from the unit circle that were my key points into the calculator. The negative 1/4, 0, and 1/4 were the key points from the other side, remember. At the negative pi over 4, we were at negative 1, we were at 0, and we are at a positive 1. So my values for the tangent, these are the 3 key points that I'm going to be looking for on my test. Again, I'm going to go up and I'm going to push clear and I'm going to do enter. In this particular problem, the 3 is a vertical stretch that affects the y value. The negative 2 is a vertical shift down, and that affects the y value. So I'm going to go into my L3, and I'm going to take my y values, which were in list 2, blue button, the number 2 picks up the list 2. I'm going to multiply that by 3, and I'm going to subtract 2. And these are now my new values. The negative pi over 4 is going to be at a negative 5. I'm going to come all the way down here and put my negative 5. And the negative pi over 4, I'm going to do my asymptotes. So negative pi over 2. At 0, I'm at the negative 2. And at pi over 4, I'm at 1. And I'm going to draw in my vertical asymptotes. And I'm just freehanding these. If you want nice, clear graphs, you're going to want to, well, you can't hardly see my writing, you're going to want to use a straight edge. Connect your dots, put arrows on the end. And our vertical asymptotes then are occurring at every pi over 2. And we are going to add our period, which in this case is pi divided by 1 is pi, times k. And that is, let me write the division that way so it doesn't look like a multiplication symbol. It's interesting to me that things look different on paper than when you're actually recording them. Sketch one cycle of the cotangent. Now remember, on cotangent, the cotangent graph is typically between the y-axis and the pi over 2. It's been shifted over, and it's also kind of, like I said, a reflection on the other one. Our period, pi divided by 3, is going to tell us our period, and I need to factor out, and this tells me a couple of different things when I go to graph these. This pi over 3 is my phase shift, and it's shifted left by pi over 3 units. Instead of being at 0, I have to go back to a pi over 3. Probably the best thing for me to do would be to count by if I count by 1/6, that is half of, so I'm gonna count by pi over 6. So 1 pi over 6, 2 pi over 6 puts me at a negative pi over 3. So instead of being at the y-axis, I've shifted back to the negative pi over 3. So I've shifted this left pi over 3 units. On the other side, when we did our key points for cotangent, the cotangent values we said were at pi over 4, because we're at 0, we've shifted it back. So let me go ahead and put in, at 0, it's going to have a undefined. So let me just start with 0.25, and then I'm going to go to pi over 2, which is a half, and then at 3 pi over 4, and my value then is negative 1, 0, and 1. Remember, it was going in downward, so our values were 1, 0, and negative 1 typically. Now, if you don't remember that, just flip over to the other side and look at what we did. When I write these in, I would have had a value over here at pi over 3. So my one full cycle is going to be pi over 3 units. When I go to my L3, I'm going to use my L2. I'm going to divide that by 3. The reason why is because we have 3 times, so we're undoing it's happening inside, and we're also going to subtract that 1/3 of pi. And I'm sure those of you in my class just got bonus points because you said, hey, wait a second. No, those are affecting the x values, which my x values were in list 1. I'm going to divide that by 3. I'm going to subtract 1/3. All right, so here are my new values for my x values. And then my y values will stay almost the same. I have this plus 2. So my L4, I'm going to put my new y values in. So I'm going to take my list 2 and I'm going to add 2. Then I'm going to quit out of here and I'm going to go into my blue 3 and I'm going to do math fraction enter. So there's my list 3 values and my list 4 values. So these are going to be my new points. Now, I don't want you to get all upset that these are 1, 4, 6s, and 12s. 4 goes into 12 3 times. So this is a negative 3/12, negative 2/12, and a negative 1/12. And then 3, 2, and 1 are going to be my new points. If my pi over 3 and my pi's over 6s, if that bothers you, you can change what you're counting by whatever you would like. I don't think that that's a very good idea because it makes it nice if you do it in the calculator this way. You may have to convert all of your denominators to the same thing, and that would help you out. So 3, 2, 1, I'm going in a negative direction, 1 full cycle. Now, my vertical asymptotes are going to be x's are equal to that pi over 3. And I realize you say that that's a negative, but it's going to start going over again over pi over 3 times k, where k is an integer. Let me stop this recording, and I will do 51